Hello everyone, welcome to ETHIndia. Thanks for joining the Lighthouse workshop. I am Ravish and let's start. So at Lighthouse, we are building a perpetual file storage protocol on top of Filecoin, which provides you ability to pay once and store your files for a very long period of time. We are proud to be an active contributor in the Filecoin ecosystem for the past 2 years. Our key focus while developing the product has always towards being the developer. So that the developers can keep focusing on building their apps while Lighthouse take care of their storage needs. At Lighthouse, we have got Lighthouse Files and Lighthouse SDK, which you can use to play around with the products and try out different features quickly. Along with that, we have Lighthouse JS SDK, which you can use to integrate into your applications. And since IPFS and Filecoin are public network, in order to maintain the privacy, users can use our Kavach library to encrypt the file while uploading it to the IPFS network. So let's have a detailed talk on the programmable storage. It's something different which you won't find in almost all the Web3 products as well. So suppose a person X wants to store the file with 2 replications. One copy should be stored in the United States and say one copy should be stored in India. It is possible with this just one line of code using these programmable storage modules of Lighthouse, and we will see shortly how it is done. So let's start building. First, let's have a tour of the file step. So if you go to files.lighthouse.storage, you will come to this UI. You can log in. You have the Solana option, EVM option, and Web2 logins like Google and GitHub. So I will be using the EVM option. So it will trigger my MetaMask. Let me sign in. And yeah, here is the dashboard. So you can upload the file, upload a folder. You can turn on the encryption, upload the file with encryption. If you want to import the file from IPFS network into Lighthouse, you can use the migration service. In order to use the SDK, you will need an API key which you can generate from here. Suppose I want an admin key, so I write admin. I click on generate, yes, and here is my key. Also, we have 2 more ways to generate the API key, which you will check in the docs section. So if I come back to dashboard and I click on a particular file, so I get the file details. So this is the file size, it was created here. This is the CID, which is the hash of file. And if you go here, you will find the storage deal. Let me click on it. So it took me to the Philfox dashboard, and here I can see few details. Firstly, let's check the piece CID. So this particular piece CID is the CID of the entire bundle that was shipped to the Filecoin miner, and within that bundle exists my file, which is 0.55 kilobytes. Although the entire bundle is of 32 gigs. So what's happening is, at Lighthouse, we aggregate your files with files of other users to create a 32 gig bundle, and then we ship this bundle to the Filecoin miner. Okay. Yeah, also you can, if you want to view the file, you can just copy the CID, go to gateway.lighthouse.storage, paste it here, and here it is. Also, you can view the file directly on the dashboard. So yeah, some formats are not supported, but image and video files you can view it directly from the dashboard as well. Now coming back to the presentation. Okay, so this diagram depicts the entire journey of file from the user to the storage miner. When the user push a file from Lighthouse, it first gets stored in the Lighthouse IPFS node. From the IPFS node, you can instantly view the file using the gateways that I just demonstrated. And also, once the file is successfully uploaded to the IPFS node of Lighthouse, we have a deal engine which fetches the file and bundles it with the files of other user. Once the 32 gig bundle is ready, this file gets shipped to the Filecoin miner and a Filecoin deal is ready. After that, you can see the Filecoin deal on the dashboard. So now let's go to the documentation. So you can go to docs.lighthouse.storage. You can have a brief overview in the intro section. In the quick start guide, you can see how you can get all the elements together and just upload a file instantly. Create an API key will show you the SDK method. If you are using any other programming language apart from JS, then you can use the APIs. So all the sections will also contain the API. So if you are building on Rust or Go, you can integrate using the APIs. And if you are using our CLI tool, you can refer to the CLI section. Then you can upload the data. In uploading the data, you can upload a file, you can upload a JSON or upload a buffer. If you want to encrypt the data and then upload it to the IPFS, then again you can encrypt the file, encrypt the JSON, and you can refer to the encryption section. Along with that, we also offer some more features on encryption, like sharing a file. So if suppose I have uploaded a file with encryption, the other user, when he will be fetching the file from IPFS gateway, he will get downloaded a binary file which he can't just decrypt. So in order to make this file viewable to that particular user, you can use a P2P share method. So you can just put his wallet address, do a authentication signature, and the file will be viewable to the other user as well. If you want to revoke the access from that user, you can refer to the revoke access section. Along with that, you can also use token gating. So in token gating, you can apply access conditions like, okay, unlock this file after this many block periods. Suppose you want to share file to your friends on his birthday. So you can do something like this. Or if you have a NFT collection deployed on any chain like Polygon, Ethereum, you can just create a condition like, okay, store my, if a particular user owns an NFT from my collection, then this file should be viewed from him. Something like this can also be built. So if you go to the access control condition section, you can see all the different kinds of conditions that you can try. First is the balance of. So in case you want to, this one is the NFT example, so you can just call the balance of method and compare if he owns the NFT or not. Then you have custom contracts. So if you have your own pre-built contract, you can just define the function that you want to invoke and match the parameters and then allow the decryption to happen to the other user. Then you can also match the native token. So if a particular user owns 1 ETH, then decrypt the file for him. Even something like that is possible, and the time-based conditions. You can go to the chain supported section to see all the chains that are currently supported. You just need to put their name in the access conditions. We will also be having look into this into further detail in the demo section. Let's explore rest. So list file, you can just use this to view all the files that you uploaded to Lighthouse. File info, you can check the metadata of the file, so file size, CID, whether it is encrypted or not, file name and MIME type. Next is get balance, you can just check the balance, so how much data cap you have, it's left. Then you can use the retrieval directly if you want to fetch the file from gateway. Then in case your Filecoin deal is ready, you can just check the status of your deal and you will get something like this. So main is this chain deal ID. Chain deal ID, you can search it on the Philfox and you can get the information of this particular deal even on the chain. So in case, since CID is hash of a file, so if you even change a bit within that file, the entire hash gets changed. So in case you have a mutable file where the file is getting uploaded again and again, but you need a constant URL. In that case, you can use the IPNS service where the URL will remain the same, you just need to change the pointer of the hash. So you can refer to the IPNS section. It's quite simple, just 4 steps and it will get done. Then the migrate file, in case you want to import all CIDs in bulk from the IPFS network into the Lighthouse. Then we have got the pinning service. It works in case you have a single CID, you just want to pin to Lighthouse, you can use the pinning service. Paper use will, so all the users are not comfortable in buying the entire, suppose 100 gigabytes at once. You just maybe have a storage need of 100 gigabytes that you want to store perpetually. In that case, we have built a service called pay per use where you can just get the quote, get the price for maybe suppose 100 megabytes, you just put your file size, then which network you want. Currently we support Filecoin mainnet and calibration net, And if you want to use native token, just type native, or if you want to use a stable coin, you can type USDC, and in case of calibration net, it's USDT. So, and you will get the price, whatever price you get, you just put it here, you can just do the parameters, the fund function, and you can pay. Once you paid, automatically your data cap will get increased, and you can upload that much particular file, maybe suppose 100 MB, 200 MB, whichever you want. And in case you just want the upload to happen in real time and you have not generated API key or anything, you can also generate a one-time auth token. It will get expired after the upload. Now resize image. So in case of gateway, if you are fetching an NFT collection and you want, suppose the file is of 19201080, the resolution is high and you want it to be 240 by 250 just to showcase it well in your site, and it also saves some space. So you can use this resize image where you can define the height and width of the file, and it will resize it and display it for you. If you are playing around with our CLI tool, you can refer to this section. Now let's upload a file. So I'm opening my VS Code. So I've already taken this code from our docs. So just to upload the file, you need two parameters. First is your file path, and second is the API key. So you just call lighthouse.upload, import the library, import the env variables, and simply give the absolute path, not a relative path, and provide the API key, and file will get uploaded. So if I just go to node index, and there it is. And if I want to view the file, I can just copy the hash, go to the gateway, replace the CID, and there it is. Okay. Coming back to the presentation. Okay, so now let's look into the programmable storage. So in order to use the programmable storage, what you just need to do is call this RAS worker, and rest of the things will be taken care by Lighthouse in the backend. So how it is working is, either you can submit your CID using our transaction in the contract, or you can call an API using post request. That I will demonstrate. After the request is registered with the RAS worker will take that CID and pin it to our IPFS node. After pinning, the deal engine will take that file and it will upload it to the Filecoin network. Okay, so once the deal is getting expired, and if you have set up a condition to renew the file, what will happen is the RAS worker will again pin the file to the IPFS network. So a file is repinned before the deal gets expired, and deal engine picks that file and again send it to the Filecoin miner. So before your deal is getting expired, you got another deal. So in this way, the deal is getting created perpetually, and we are also using this RAS worker quite extensively in our perpetual model. So if you want to use the RAS worker, let me go to the RAS code example. So I will close this. Okay, I closed the other one. Sorry. Not this. Okay, so in order to register your CID, you just need CID, and even the rest of the parameters can be default, and if you want to define the parameters, you can do so. So I have created a signer, then I have created the contract object. The contract address you will find in the docs as well, and also I have put this code in my Git repo. You can find all the code examples that I am demonstrating here in my GitHub. Then I have created the contract object. This is my CID which I want to register. I have converted CID into hex. Now I am calling the submit RAS function. So first parameter is the CID, second is the number of replications, how many copies you want. Third is when the deal is getting expired. So if the miner is defaulting on a deal, he is not submitting the proof. So after how many epochs, if the default is happening, should the deal get renewed, means our copy should get created with another miner. And final one is the increase the, so when the deal is getting expired, so you can define before how many days the deal gets expired, should the deal get renewed. So suppose on an average, in a day there are 2880 epochs in the Filecoin network. So if you want to do it 10 days before the deal gets expired, you just do it 28800 like this, and this happens. So if I, so this one will take little time, so transaction takes around a minute. So to save the time, let's check the deal status and let's have a discussion on the pot side. So once your CID is registered in the test network, you will get a deal within 20 to 25 minutes, and you can check the status of your deal using this API. Everything is also in the docs. You can refer to the FVM section. So calibration.lighthouse.storage API deal status, put your CID. Okay, so for this particular CID, deal is already been created, and you will get a response like this. These are the current active deals. Then this one was the transaction ID. These are the deal IDs. You can, okay, let's check one in Philfox as well. So in case of calibration net, you go to deal and just paste your deal ID. And here it is. So you can check the Filecoin miner. The deal size is 16 MB. So in the testnet, the miner supports files from starting from 4 megabytes. So you can even create deals for small file sizes. So the transaction is done. You get a response like this. Okay, so once the deal is gets created, you can use PotSci. It's to get the file proof. So I will just give you an overview. What happens is we use this file proof data to recreate this piece CID, and this piece CID you can verify it on chain. It should match with this piece CID. So this means that the piece CID which is shown by us actually has an on chain record, and using these file proof parameters, it proves that your file was part of this particular piece CID. In this way, you can be sure that, okay, in this 32 gig bundle, my file is also present. Coming back to the presentation, so we have already discussed the programmable access control in brief. So how it is working internally is we generate a random key at the user's end. That key is splitted into 5 shards, and those shards gets independently stored in 5 different nodes. Currently these nodes are hosted by Lighthouse, but we do have our decentralization plan here as well. And we use this random key to encrypt and upload the file to the IPFS. In this way, you have an encrypted file uploaded to the IPFS network. In a similar fashion, the decrypt one, you just request the shards and generate the original key at the user's end, get the file from the IPFS network and decrypt it. Okay, we also have passkey feature in the encryption, where you can use your fingerprint, or from your mobile phone you can decrypt the file. In the documentation, you can find the passkey here in the authentication section. You can even refer to this. Next, pay and fill is the paper deal, which we just discussed. Now coming to the bounties. So we have 2 bounties. First is best use case of our programmable users functionalities, $2,000, and best overall use case of Lighthouse SDK is split it among 2 teams, $3,000. Here are some common use cases. You can create perpetual renewable storage using these programmable storage, data DAOs, and time logged access conditions, and more. Okay, in case you have any query, you can ping me on Twitter, Telegram, or you can also write us on the Discord. This is the Lighthouse Discord, and you can even write us on the ETH Global Discord. Yeah, thank you.
One reminder, we're at workshop 2. If they want any help, we are in the Filecoin booth.
Yeah, and I'm also present in the Filecoin booth. You can just directly contact me.
They have a HDMI connector?
Oh yeah, HDMI should be here. Hey everyone. Hey everyone, this is Guru. In this workshop, we'll be looking at how Vaku is uncompromising Web3 communications at scale. So introducing Vaku, it's a family of robust, censorship resistant and private family of communication protocols designed to enable privacy first messaging applications. When I say messaging, it's not restricted to chat but anything within the space which requires multiple parties to communicate with each other. So the 6 main values of Vaku are: it's private out of the box, it's censorship resistant, meaning that the messages in the network cannot be censored by any centralized stakeholder. It's also modular, meaning that it can run with any blockchain. It's something that complements a blockchain but not a blockchain. It's also adaptive and can run in any device, in your mobile phone or in your browser, even in a DApp node or a big cluster. So it's adaptive to any bandwidth. And it's also securely scalable. We use sharding to scale it across multiple devices and multiple content topics. It's also rate limited. We have a technology called RLN, which I'll be showcasing in a couple of next slides. So it's completely decentralized, and we are one of those protocols with a completely decentralized stack of rate limiting. Talking about the history, it all started in 2013 with the Ethereum white paper, when the holy trinity of decentralized web was introduced. So Ethereum was for consensus, Swarm was for storage, and Whisper was for generalized messaging. But there were not much of dedicated teams building on top of Whisper. So in 2019, we started building Vaku V1, and 2020, Vaku V1 replaced Whisper in the status app. So this was a huge benchmark because status app is one of the well-known communications app in the Web3 space. And today Vaku has evolved into a standard for Web3 communications. So we have a vibrant ecosystem where we have Status, who is a Web3 messaging app. Railgun is a privacy layer built on top of Ethereum. The Graph is also using Vaku for decentralizing its indexers and a couple of more use cases. And XMTP is also built on top of Vaku for this specific use case, which is chat messaging. So the key features of Vaku are it's adaptive. As I mentioned earlier, it can cater any kind of resource restricted environment. So on the left you have clusters which have more bandwidth, and on the right you have browsers which have very less bandwidth. So we have different implementations for each of these different resource restricted environments. And it's also rate limited. We have rate limiting nullifiers, which is a truly decentralized anonymous rate limiting technology with ZK proofs. So we have a membership contract on the blockchain which can basically find if Alice is trying to spam your network or if Alice is trying to DOS your network. So DOS protection is something that we've been working on over the last couple of months. And it's also open and permissionless network. We are built on top of libp2p's PubSub, so gossip sub. So it's a fleet of nodes running the PubSub topic architecture. So we have a lot of content topics within the Vaku network. So it's basically like users can push messages into any content topic and also subscribe to content topics to retrieve messages. So we have 3 key protocols, especially for hackers to target during ETHIndia. The first one is light push. which can be used for pushing a data into a content topic. Filter can be used for retrieving data from a content topic, and store is basically a temporary storage protocol. At this point, I also wish to mention that store is not meant to be exploited. It's not something for long-term storage. So since Waku is a communications protocol, it's better to use something like IPFS or codecs for maintaining your long-term storage needs. So getting started with Waku, you have two ways of doing it. You can either operate a node and contribute to the Waku network, or you can build on top of Waku. So operating a Waku node might be a bit off topic for hackers, but then in simple words, we have three different implementations and ways of hosting your own Waku node. You can use our nwaku, which is available. We have binaries available on GitHub, and we also have a Docker compose command for you to get started without much friction. And we have a dApp node integration as well, so you can run your own Waku node in a matter of few clicks. And building on top of Waku is where we focus for hackathons. So we have different Waku SDKs like JS Waku, which is our JavaScript implementation. nwaku is a NIM implementation, Golang implementation. We also have Rust bindings and C bindings. So yeah, coming to the resources, we have a developer documentation at docs.waku.org. So this will be a holy grail to get started with Waku, and it has pretty much all about the protocols and use cases about Waku. And we also, all the code is open source on GitHub, so you can find all the examples on GitHub as well. And we have examples.waku.org where we have like around 5 or 6 examples that use Waku's protocols. So it's a pretty good place to get some references. And all the research articles and RFCs will be available at rfc.wac.dev. So we have all the RFCs available, and it's been, it has a repository of work of over last 2 or 3 years. So definitely check it out. And for ETHIndia, we have bounties worth $10,000. So the grand prize winner will be bagging $4,000 for the overall best implementation of Waku. We also have 4 different track prizes. We have best network state goods using Waku. We have most innovative project using Waku, and best privacy focused project using Waku, and a track dedicated for gaming and marketplaces. So about the bounties, all the bounties are focused to non-chat projects. So we are not really encouraging chat projects at this point because we have a lot of chat projects around Waku already. So some of the example use cases over here will be gaming. So you can build games with Waku where you make all the game state communications through Waku. You can also build decentralized marketplaces where, for example, if you are building a NFT marketplace that can have elements of Waku and that can decentralize the centralized parts of the currently available marketplaces to a great extent. And also state channels is something that a lot of hackers have been building over the last few hackathons, so that's an important use case as well. And it's basically like you can build anything related to communications with Waku. And you can check out more ideas about Waku, around 50 ideas that we curated for hackers to check out at ideas.waku.org. You can also scan the QR. So also shout out to Waku's network launch. We just launched our network a day ago, so make sure to tweet it out, help us amplify the announcement, and come to our booth for getting some swag. And yes, you can join us on Discord. We have some active conversations going on over there. So after this, we'll be building something simple with Waku in the next few minutes. So I'll have my colleague Sasha joining me.
Should I bring another?
You can use this one. Yeah, this is the code base, and then if you want, you can just use the local host here. Oh yeah.
Hello, my name is Sasha.
Perfect. Thanks, man.
Today I will show you how to create a simple game.
Do you hear me now? Cool, yeah. So I will show you how to create a simple game by using our React hooks. This game is tic-tac-toe, and I will show you in a second. So this is the game. Let's create a new one. So the game has been created. Let's go to and join it. So now we are joining, take some time. We are using the test fleet here, so please expect some delays. There is a production fleet with better timing. So here it is. It says like open and turn. Let's do this. So I'm in the open and tab, and I do the turn. So as simple as that. If you continue, this will be like a tic-tac-toe game. Everyone knows it. I won't continue. So I will show you the code, the most important part of it, and I will introduce you to React hooks. React hooks have the naming of. Everyone sees the code. It's okay. Yeah. So it's named like simple as Vaku/React. I just install it. And first thing that you need to do is to create an abstraction to connect to the network. And we call it a node. And a node that operates over the light protocols is called light node. Light protocols, as Guru said just now, it's light push, filter, and store. So here we configure the node. And I advise you to use this default bootstrap, which allows you to connect to available nodes in the network, so it does a job for you. If you want to experiment more, you can run your own node and connect to it by using a multi-address. It's very straightforward. Come to our booth, we will help you with some edge cases if you might notice. And here we mentioned protocols that we want to use. And again, these are the light protocols. They may be mentioned. If you don't mention them here, the light protocols by default will be used. So this is a holy trinity of light protocols here. So yeah, this is the provider, React provider. What it does is that just puts this abstraction into React rendering tree, and then we just get it. Let's say we created the game, and another thing to mention is that Vaku operates over, it is unbiased and it is unopinionated. So it just takes care of transferring bytes from endpoints, which means that we need to create encoder and decoder to read from this stream of bytes. And for that, we have also a solution which is called Content Pair Provider. It creates an encoder and decoder for us, and it puts into the context as well. So you just take it, as simple as that. And what we operate over is a content topic, and content topic is the abstraction that you should familiarize yourself with, and it allows you to send something to some particular place. It's like a room right now. I'm broadcasting some messages to you, and it could be like one content topic. I may want to broadcast a message to someone here in particular, but overall everyone hears it. This is how Vaku works in a nutshell. And yeah, so we created encoder, decoder. Let's go to the juicy part. So here I'm highlighting the line where we are getting the abstraction from the network, and we might do something with this. In this particular case, we are passing it, we are using it to retrieve messages. And there are two ways to retrieve messages. One way is to retrieve messages ad hoc. This is called filter. We essentially subscribe to the stream of messages which are happening after we started the subscription. And in this line, we essentially subscribe to it. There is a hook, it does it for you. It will start iterating and it will be keeping updating the messages. You just get it. And as well as the second way to get the messages is the store. And this allows you to get messages which were there exchanged in the network while you were offline. So to do that, there are 3 lines. So essentially like this. Later on, we can do some stuff with messages. We might want to combine them together and like get only one blob of messages and then iterate over it. This is very straightforward. And okay, what we can do else? Now we have a way to get messages from the past, get messages from recent, like from now, and now we want to send messages, right? So to do that, there is a hook. It's called light push, and what it does is that you just throw in it some, here is this line. You get the push function. What it does is that it receives payload and some timestamp. What it would do, beneath this abstraction, it will create a protobuf for us, which follows the Waku message convention protobuf, and essentially an entity in the network which is exchanged everywhere. This is the language nodes speak to each other. And there is one field reserved for it, and which is called, I will show you. So please refer to this site if you have any questions, or to us, of course. Yeah, let's go. So learn here. So content topic. There is more information about content topic. It follows some convention, so please don't break it, because otherwise the experience might be working, might be not. No one guarantees. This is short description of protocols. We covered here filter, store, and light push. There are some other protocols. If you are curious, come to us. We will educate you on these primitives. The Waku message. Waku message is as I said, this is entity in the network. This is universal language we speak. It consists of content topic, the place where we want to send messages, and the payload. And payload is the place where we put our information, just bytes. You can do encryption on top. You might do it, you might not. Other things that you might want to consider is to check out the other places in our documentation. I showed you right now how to use Waku React hooks. But if you want to have like a little bit of more of complexity, you might want to do some tricky stuff. I don't know, like maybe writing into some database, writing to some fancy cache messages, like rebroadcasting it, maybe using some conflict-free data structures. For that, maybe a better way to use is to import the Waku CDK package. And Waku CDK package has like role abstractions, which you need to use in order to achieve the goal, whatever you want, you have in mind. And please come to us again, we will help you. So this is our job today. Yeah, this is pretty much it.
So make sure to come to our booth to get your goodie bags. And if you have any questions, I can take 1 or 2 questions right now and then go on one-on-one after that. Yeah, please. Hello.
So before I ask you a question, like I'll just summarize to get some context. So the idea is that you have 2 different entities that can be blockchains or like even different nodes, and the idea is to build a communication channel between the 2.
Exactly, not specific to chat, but anything. For example, in the tic-tac-toe game, we use it as a game state communication. So when you press the first box, the number 1 is getting relayed into Waku network, into the content topic.
Understood. Now my main question is, can we actually have 2 different contracts interacting with each other? I'm talking about like the same chain or maybe even different chains. So yeah.
Yeah, definitely. It's cross-chain interoperable because it's not linked to a specific blockchain. But yeah, it's definitely possible. You can listen to events being emitted using maybe a server. It's definitely possible with a server, but we encourage more of serverless dApps built directly on Waku.
Well, like when I'm talking about the same chain, I mean like the entities being 2 different contracts. Can they interact? Like, can they have a messaging protocol between the 2?
Yeah, definitely. It's definitely possible. Yeah.
All right. We could probably take one more question if you don't mind letting the next speaker set up on stage. You can use this microphone.
Perfect. There's one.
Can I unplug your computer?
Oh, yeah.
Go ahead, take the question.
Perfect. Yeah. What's your question? I can answer one more here. Okay, so with Waku, we don't consider encryption as a big part of our libraries, but then we definitely have some standard encryptions implemented already. So you can use encoders and decoders from Waku's library, which are out of the box, but we definitely recommend people to use Crypto.js or some dedicated RSA library if you want to make some access controls and stuff. Yeah, we definitely have some standard basic libraries inside, but then it's better to do it outside if you want to make it more flexible. So, yep, no problems.
Thank you very much, Waku. All right.
Yeah. Hey, test. Is it okay? Okay. Okay, all right. Hello, everybody. I hope that you're as excited as I am for this great hackathon weekend. So I'm Yanis. I'm part of a team called PSE, which is under the umbrella of Ethereum Foundation, and we are working on a protocol called Anonadar. So what's Anonadar? Anonadar is a zero-knowledge protocol that allows you any Indian citizens to prove their identity in a privacy-preserving way. So I'm going to go into details about what problem we are solving. So let's say that you're a citizen, you have an issuer, which is the government. In the case of Aadhaar, it's, for example, the UA DIA, which is the signer of your ID. So they give you your ID. So basically, okay, you have a number, you're a citizen or a resident in the case of Aadhaar. So the goal of it is like you need to give your information to a prover, and the goal for this prover is like to prove a verifier that you're a citizen without revealing any information about your who you are. So that's what we are achieving with Anonadar. So how does it work? So we are relying on the e-Aadhaar. It's also work on the the masked e-Aadhaar. So we're in this PDF, you have a signature, and you have also the hash of the PDF. So we are just querying like these two informations, and with these two informations, we're gonna check this information. So what's happening? So you have in the PDF the hash of the PDF, which is the hash of all the contents of the PDF, and this hash is signed with RSA. So we are querying the information, the signature and the hash inside of the PDF. We are fetching the official RSA public key of the UIDI, and so we are going to verify the RSA signature. So RSA lets you like easily verify the signature. So what is the innovation here with Anonadar is that we are doing it like inside of a snark, resulting in a proof that this RSA verification was done in the proper way with some inputs, with secured inputs, and resulting in a proof of residency that does not reveal any information about you. So here is just the logic about the circuit and how it is the process of proving. So you have the RSA public key, which is public because we need it public because you can use the circuits to verify any RSA signature. So to verify that you are to acknowledge the fact that you prove UIDI document, we need their public key, and we need it to be public because anyone who's verifying your snark proof needs to see that you used the official public key as an input. As a private input, you have like the RSA signature. Also, the PDF hash is private here because we don't want to reveal any information about yourself. And you have an application ID. So we use the application ID and the PDF hash to hash it, and the output of the circuit is a nullifier. So the nullifier, you can see it as a unique ID. So let's say that you want to prevent someone like to double spend their proof into your apps. You can use the nullifier to nullify the user. So you can verify, for example, a proof in your front end. You query the nullifier, and you can send the nullifier to your backend or to your smart contract. And so this is the variable that you will need to nullify, because the nullifier is supposed to be the same for the same PDF. So we did all the complicated part. So now let's abstract a bit this complexity, and let's onboard you on how you can like use this primitive like into your apps during this weekend. So we built a SDK that lets you seamlessly like import what we did. So what you just have to do is like to generate an app ID. You can run this small script and take the output of this script. You just have to add our SDK and our provider alongside your app ID, and then you have like a hook and a connect component that you can use into your apps. So this is like you can do it like under 5 minutes, and you can add like a privacy layer onto your apps. You can build like Sybil resistance use cases, and you can build also like let's say that you want to build, I don't know, like a Twitter just for ADA residents. You can build it with it like very easily. So the SDK will serve you like these components. So this is the flow that you need to do. So you need to upload like your masked ADA PDF, and you need to enter your ADA PDF. So as I said, as I show you, so you have like the extraction part. So when you upload the PDF, we are going to search for the signature, and we are going to search for the hash. So that's what we are doing here. And the password help us like to first ensure that you are the owner of the PDF that you are uploading. And secondly, like we need it to query, like for example, a certificate. So the certificate is where like all the information about the signature process is stored. So just want to highlight here, so everything runs locally, meaning that in the process, nothing is shared to anybody about the ADA PDF. It's just that everything runs in the browser within the SDK. So you don't need to send any information to your backends, any information to the chain, whatever. You just need to use the SDK, the user upload their documents, and they can like locally prove their identity, resulting in a PCD proof. I will talk more about PCD after that. And so you can use this proof to authenticate a user, to nullify their interaction and stuff. So everything is handled by the SDK actually. Just want to highlight that what ensure here privacy and data security is that everything happen like locally on the browser. Yes, so in the documentation you will see that you can download like a test PDF. So this PDF is like a fake PDF that is emulating the specification of the EADAR PDF. So it has like a RSA signature, and you can use it like for developments. In the case like, so by default, the SDK will be able like to verify both the test file and both your real masked ADAR if you want to test with your real masked ADAR. Why? Because by default, it will just verify the RSA signature. And as the fake document and the real document have real signature, as I said earlier, what we need to ensure that it is like really like EADAR that you're verifying is by inputting the official public key. So in the SDK, you have a mode, you have a testing mode, and so if you want like to, for example, like to generate a real proof of your real EADAR and a proof with the following statement, I have like a document that is signed. I have an EADAR that is signed by the UIDI. So in this case, you can put the testing mode to false, and you will be able like to generate a real proof of your EADAR. But yeah, you still have like a testing mode. You can use like the signed PDF and the password if you don't feel comfortable like developing with your real ADAR. It's not something that we will require you to do. Like even if you're in your video demo, like you're using like the test PDF, the signed PDF, it's completely okay. We understand that it can be like quite sensitive, like to upload your EADAR, so it's up to you. So let's talk about the proof format. So in the SDK, when you will generate a proof, you will authenticate the user, and this proof will be written into your browser. So what's in there? So you have a type, which is the name of our PCD, the Anon ADAR PCD. You have an ID. Just want to highlight here, this ID should not be used. It's like just a random UU ID. Don't don't do anything with it. It's like just dump data. You have a claim. So what is the modulus? The modulus is the public key. So again, you can always verify that someone like generated like a real proof by querying the modulus inside storage inside of the proof. And you have like also the nullifier. So as I said, the nullifier should be like the variable that you need to use in order to nullify any interaction. Let's say that you want like to create like a voting platform on chain or off chain. You can like use the nullifier to say, okay, so this is a unique user, and assign a boolean to this nullifier and say, okay, true, false. Does he voted? Yes, no. And then you have like the proof, which is a gross 16 proof. You have also the app ID, which is the app ID that is the input of the circuit. Okay, so the SDK also provide a solidity verifier. So what you will find in the package Anonada contracts is just a basic gross 16 verifier. But to verify proofs on chain, you need like to add some more logics. For example, as I said, you need to check the modulus, for example, and plus you need to ensure some cryptographic tricks that can be done over verifying snark proofs on Solidity. So that's why, so at the end, I will give you like the QR code of the GitHub repo. Inside of this repo, you will have a link to the example app. In this example app, you have like all the contracts, an implementation on how you should verify proof on chain. You can forward this app, another example, or copy paste the contracts and the configurations that are there. Yeah. So just want to highlight, yeah. So don't just use like the verifier. Check also like this example because it have like some security layer that you will need like to check proofs on chain. So let's talk about like what you can do this weekend with Anonadar. So Anonadar can be used like mainly like if you want Sybil resistant use cases, if you want use cases that are that you want to enable only for Adar residents, and it can also be used like for anonymous KYC or proof of humanity. You want your users like to prove that they are human, so you can basically verify their EADAR with Anonadar, and you will ensure that they are an Adar resident and a human. Yeah. So the prizes. So we have 3 tracks. We have the main track, which will be all the application that integrates the Anonadar SDK can apply to this track. So the judging criteria will be like the technical implementation. We are going to check like if you really like use the SDK into your app. Also like does it solve a problem into your app? And also like in terms of UX, like and the flow of your application and the problem that it solves. I'm just heading to the last one. Best social goods build with Anonadar. So this this track is like we are going to judge, of course, like the technical implementation and if Anonadar solve a problem in your application. But we mostly want to highlight the project that have the most potential social impact. And so the best implementation of Anonadar on mobile. So that's a bit a special prize because at first we thought about it like because for now you can only verify you can only like have the proving flow like on web application. So our circuits are built with Circom, and so the backend is gross 16. But you have some way to compile the files needed like to compute the proof, so they can run natively on mobile. So you have 2 solutions to do that. You can use a project called MoPro, or you can use Rapid Snark, which is a compiler developed by Iden3. So this is a bit more technical, and this is a bit more low level. But just want to highlight here that you, of course, like if we have a team that achieve like a real mobile proving by compiling the circuits for mobile, there will be, it's gonna be crazy and super cool. Just want to highlight that if we don't have a team that achieve to do that, we will still reward like the best implementation that runs on mobile. So it can be like, for example, a progressive web application. So it's gonna be browser proving in browser. But yeah, just want to highlight here that it's okay. It's okay if you want like to don't have like all the hassle of doing pretty low level stuff. You can still build it this way. And yeah, so that's the link to the GitHub repo. Don't hesitate to pass by our booth to ask all your questions. And I think we have a bit of time for some questions.
Any questions for Anand?
Yeah. So in the example, so sorry, the question is on which chains we developed we deployed our contract. So you have an example app. We deployed them on Goerli, but just want to highlight that it's Solidity, so you can like. We just before the workshop we just tested our verifier contracts on Scroll, and it works perfectly. So you can use Scroll. You can verify Gross 16 our Gross 16 proofs on Scroll. Go to their booth because it's someone from their team that did that. So yeah. Is there any other questions? Inside of a snark, the hash of the PDF, and the PDF is like too big, and it's going to be too expensive to do this in a snark. So it's only been 5 months since we started to work on this project. We work on a new version that will solve a lot of problems, and especially we are going to change the protocol so you can do what you are highlighting here. So it's not possible in the protocol right now. In the future iterations, yes, but if you have like a use case in your app where it needs to make the assumption that okay, I can prove my edge through Adar, or I can prove my where I live, my address, you can say that in the documentation of your hack, and yeah, we can make the assumption that it's going to be possible in the future. Yeah.
Thank you, brother. Great job. All right, now we.
Hello. I have something. I have a Google account. Do you have a Google account? Yes? And you? Do you have a Google account? Yeah? And you on the back? Do you have a Google account? And you? Do you have a Google account? Yes? Well, then let me tell you something. If you have Google, you have Safe. You maybe just didn't know, but we will see that today. So we are going to talk about enabling smart account portability with SafeAuth. This is the logo of SafeAuth, our new product. And we have created a formula that is very cool, and I hope it's easy to understand, that you'll see why this design. So safe auth, it's equal safe, you see that some similarities, plus Web3 auth. Well, in reality, it's not just a sum, but a multiplication, because the sum, the final product is much better than the sum of both of them. But first of all, I have some questions for you. First of all, do you know what safe is? Can you raise your hand if you know about safe? Okay. Well, safe is a smart account protocol. We are trying to build a universal smart account standard. Safe is used by a lot of DAOs and companies to manage their treasuries, also by individuals, and it's on individuals what we want to focus nowadays, especially with this solution, Safe Auth. Also, the second question, do you know what Web3 auth is? Can you raise your hand if you know about them? Okay. Web3 auth is leading the wallet as a service provider. They have an MPC, multi-party computation solution that allow users with a social login like email or Google account or Facebook or whatever to generate an EOA, creating a seamless experience. And the final question is, do you know what Safe Auth is? Can you raise your hand? Okay, very cool. We are going to talk about this today. So let's start with some context from Safe, as this is a collaboration between Safe and Web3 auth. I'm from Safe. I'm Germán. I think I didn't introduce myself. So some context about this. We have the Safe Core Account Abstraction SDK that has 4 libraries or kits: the auth kit, the protocol kit, the on-ramp kit, and the relay kit. All of them together will create a more familiar experience for users that are coming from Web2 world. So with the auth kit, first of all, for each of these kits, we decided to go with a third-party provider that supports the functionality for each of them. So the auth kit allows to logging. So users, via their social login, can create an externally owned account. Protocol kit offers or expose the safe functionality. If you want to deploy a safe, or if you want to execute a safe transaction, all that kind of tasks. The on-ramp kit allows to fund a safe, an account with fiat, and transform that into crypto. And the relay kit will allow to execute transactions without the signers of the safe. They don't need to have gas to execute these transactions. A relay can execute that for them. So now let's imagine a situation where a user that has no wallet and no crypto goes into an application that is, let's say, an NFT marketplace with a shopping cart where they can add NFTs to the shopping cart and buy them, but they don't have nothing. How all these kits would help them if you integrate this in your app. The auth kit will allow them to type their email, for example, generate an EOA. Also, we can calculate a safe address based on this EOA, because it will be deployed later in a deterministic way. Then the protocol kit behind the scenes will create a batch transaction after the user selects all the NFTs they want to purchase. This batch transaction will contain first a transaction that will deploy the safe, and second, all the transactions, if there are multiple, to buy the NFTs from the safe. Then the on-ramp kit will allow users to fund their non-existent safe until that moment and fund this address. So they will be able to purchase the assets later. And finally, the relay kit will allow to execute the batch transaction, deploying the safe, and executing all the next transactions to buy the NFTs. And regarding the fees, they could be sponsored by the relay itself, or they could be extracted from the safe. this is what we had initially. The third-party providers we are using for them are Web3 Auth for logging, Stripe and Monerium for on-ramp, and Gelato for relay. In the future, we may have more kits like recovery, multi-chain kit, and well, whatever comes. You can find this in the repo SafeCore SDK in the Safe Global organization on GitHub. These are the NPM packages, but now we want to focus on the auth kit, which is the one that contains the Safe Auth pack, the one we are showing today. So what is Safe Auth? Safe Auth is the first easy-to-use portable smart account solution. Safe Auth is a new NPC product that is developed between Safe and Web3 Auth that will allow safes to be portable between different applications using social logging. So what are the key features and benefits? The first of all is the deterministic address generation using this, the same social logging. So until now, if you use Web3 Auth directly, you'll see that if you connect to different accounts, a different EOA will be generated for each of them. So in the end, you will end up with assets distributed in different accounts, and that it's a bit difficult to track. And then if these accounts deploy safes, it will be, well, a little bit difficult to track. So Safe Auth allows to generate EOAs deterministically. That, as a result, will means that wherever application you are logged in, you'll see always the same safe. On top of that, our official frontend, the Safe Wallet, is compatible with Safe Auth, so you can log in with your email, with your Gmail. That's why if you got Google, you got Safe. And you will be able to track all your history of activity that you did on different applications. Also, SafeAuth supports multi-factor authentication, and it's flexible because it allows developers to choose which methods they want to use, like SMS OTP or an authentication app or whatever. And also, SafeAuth is built on Safe, meaning that is future-proofed and modular, as you don't need to deploy a new Safe if a new functionality comes to the market. You can just enable that new module or whatever. So let's see some code on how to use SafeAuth. There are some steps. First of all, you would need to install the SafeAuth kit that is inside the auth kit. Then you have to create the SafeAuth pack instance. You can sign in or sign out as a user. You can get the provider that the MPC solution returns. You can create a Safe account. You can sign and execute Safe transactions. And you can sign messages from the EOA. So to begin with, installing the SafeAuth kit, you can just type in the console npm or yarn install and the name of the package. Then to create an instance of the SafeAuth pack, if you go to the last two lines, you'll see that we are initializing or creating an instance of the SafeAuth pack, and then we are initializing it by calling the init method and passing some configuration, some options, which are this object here. If you see, for example, the chain config, you'll see inside some information about the network you are connected to, the name of the native token, the RPC URL, the blockchain, the block explorer, etc. Then as a user, if you want to sign in with your email and get this pop-up open so you can select your Google account, that could be opened by calling the SafeAuth pack instance.signin, that method. And this will return an object with two properties, EOA, which is the one returned by the MPC provider, the signer, and then a list of safes in case this signer already is an owner of any kind of safe. Then the developers would be able to decide which safe they want to select. As a user, if you want to sign out, just safeauthpack.signout. You can get the provider from the MPC, safeauthpack.getProvider. And here, one of the most important things, you can create a safe account. If we go from the bottom to the top, I think that will be easier to follow. At the very end, we see a console log. The safe has been created by calling safe.getAddress. But how do we get that safe? In the previous line, we see that we are calling the safe factory.deploySafe with some configuration. That configuration is the threshold, which is 1 in this case, and the list of owners, the signers. Here, we want to use the EOA we got from the MPC. So we are calling safeauth sign in response.eoa. That will be the address. How do we get the safe factory to deploy this safe? In the previous line, we see that we are calling safefactory.create, passing an ETH adapter. This ETH adapter is just a wrapper of the libraries Ethers.js or Web3.js, depending on what you are using on your application. This ETH adapter, we can get it by calling the Ethers adapter class, passing, in this case, an instance of Ethers and a signer. This signer, if we go to the previous line, we see that we are getting from provider.getSigner, and this provider, in the first line, we are getting it from the safeauthpack.getProvider. So that's how we deploy a safe where the signer is the EOA from the MPC, from Web3auth. After that, we can execute transactions and sign them previously. So with this signer and the ETH adapter and also the safe address that we get from the array of safes, and here is where the developer can choose the one to display or to use. And at the very end, we initialize an instance of the protocol kit, if you remember, the one that is exposing the safe functionality. So for that, we need to pass the ETH adapter and the safe address. Now we need to create the transaction object. So we can build an object with the properties to value and data. Here it's just a random transaction from the safe to the signer, but whatever you need to execute. Then we call the protocol kit dot create transaction, and we pass this transaction object. Then we need to sign the transaction, so we can call the protocol kit dot sign transaction, and we pass the safe transaction. And this will return the TX object that we need to pass to the execute transaction method. If you want to sign messages with Web3 or Ethers, not from the safe, but from the signer you got from the MPC, you can initialize your Web3 instance or Ethers, we will see later, with the provider from the MPC, and then call the methods to sign a message or sign a transaction or send a transaction. So very similar with Ethers. Now, if we have some time for a quick demo, you'll see that in the SafeCore SDK package on GitHub, in the folder packages, in the folder authkit, in the folder example, you'll see some code you can execute locally. And it looks something like this, where you can have a login button that will show this pop-up, where you can sign in with your email, with your Google account. Let's see how the internet connection goes. Here it will ask for my email. This is also compatible with the Safe Wallet. So later you can see here what is your activity. Okay. I clicked the wrong button. My fault. You'll see that this is very dependent on the connection, the speed. And now in the website, in the application, we will see on the left a list of RPC methods that the MPC is providing that you can execute. On the right side, there will be a console where the response for these RPC calls will be shown. You'll see here on the left side, on the top, the signer account that is generated from the provider. And in the middle, you'll see if there is any safe that belongs to this signer. This is taking too long because of the connection. Now it's going. It will load in a bit. Okay, so here you see that from my email account on the top right is saying hello Herman, because it's information I have on Google. Then here is showing my EOA, the signer. I don't have any safe deployed here, but you can do some RPC calls to get the user info or the accounts that I have, or the chain ID, whatever. If we connect to a different network like Gurley, you'll see that with the same EOA, I do have a deployed safe that belongs to this signer. So it should load. Well, I guess you can try it by yourself. I will continue with the slides, and then if we have more time. So for the hackathon about this, we have the Safe Ecosystem Foundation has 10K up for grabs, and we have 3 different tracks. The first one is related with this SDK, the Safe Core Account Abstraction SDK. We have two prices of 2K each. At least you would need to integrate 2 of these kits with a special mention, and we encourage you to use the Safe Auth pack. The second track is related with the Safe Core protocol, 2 prices of 2K each, integrating or implementing any part of the Safe Core protocol with plugin, hooks, the manager, the registry. And the last one is a collaboration with Pimlico. We have a Safe 4337 module that you can plug into your Safe and execute with using the Pimlico infrastructure. They also have an SDK called permissionless.js. There's information in our docs and on their site as well. We have a hackathon success guide with some learning materials, past workshops and hackathon ideas. If you want to check it, feel free to scan this QR code. Okay. And then these are our docs, docs.safe.global, Discord, forum, Twitter @safe. So thank you very much. And just one quick check here. Yes, now it loaded. We see that on Gurley, this EOA has a safe account. And now if I can try to, on Gurley, to connect on the official with the same email, you'll be able to, well, I guess the internet is not working properly, but you will be able to access to your same safe. So thank you very much for attending.
Awesome, thank you. We don't have time for questions, but next we have our friends from Cello. Let's go.
Uh, yeah. So congratulations on making for this hackathon ETHIndia. I know it was difficult, but yeah, my name is Vivel and it's not visible. The slides are not visible. Oh yeah, it's it. Yeah. So my name is Vivel and I'm here with my colleague Harpal. We both work at Cello Foundation as a developer relations engineer. And this hackathon is all about building for real on Cello. So yeah, this is the future we want. Like when we all started working on a hackathon, we all were in a zone that will create the next big thing. And yeah, we all want a future like this. But current the reality is this. Yeah, and we know it's harsh truth, but we'll make it. So let's see. What we are doing at this hackathon is building with purpose and building for billions. And yeah, this is our motto right now. And how we are doing it is with Cello L2. So currently Cello is a layer 1 blockchain, but we are into a transition. We are transitioning into a layer 2 right now. And yeah, if you want to learn more about it, like what is happening and how we are transitioning into L2, there are really good podcasts that we have available right now. So you can go check it out. It's really good. Like if you need a really technical knowledge, yeah, I will highly recommend you to check it out. Let's talk what Cello is. So Cello is totally fully EVM compatible layer 1 blockchain, and we are transitioning into layer 2. It's built for ease of use. Like it has a really low gas fees and it's totally EVM compatible. So if you know how to build on Ethereum, you're good to go. We are mobile focused. So our always motive was to build mobile first application, because if you want to scale, mobile is the way to go. To be honest, like that's what I also think. Like if you want to build projects for the billions, you have to build for mobile first. It's gas payable by tokens. So you might know, like if you're building for different blockchains, you need the native tokens to pay the gas fees. But at Cello, you can use stable tokens or multiple ERC20 tokens to pay the gas fees as well. We are carbon negative. So we launched 3 years ago on Earth Day, and since then we've been carbon negative. And actually, recently we passed a proposal where if you percentage of gas fees is used to offset the carbon. So yeah, in this way we are maintaining our carbon negativity. And recently we have seen a huge user base. If you can see, since May we have been getting a lot of new users, and most of them are like not just the bots but active users that are using a lot of new dApps on Cello blockchain, and we want to continue that. So if you see on the stats right now, if you can see the last 180 days, it's 191% increase. So yeah, it's going good. I want to take some time and talk about MiniPay. So MiniPay is a really good, really simplistic UI based crypto wallet that is built on top of Opera browser. So Opera is a browser that is like really, really famous in Africa, and they have partnered with us to create a crypto wallet built inside a browser. So anyone who has a Opera browser can have a MiniPay wallet inside it. And we also have one more similar product called Velora. Velora is a crypto wallet which you can use to send transactions. Like you can use to send stable tokens to your friends. Really easy. Like all you need is a phone number, because in Cello you can map your wallet address with a phone number. So you doesn't have to remember your friends or someone's wallet address. All you need is their phone number. You can just send the tokens to phone number, and using Velora, they'll do the resolve and they'll send the tokens to the correct address. Let's talk about bounties. So we have total $10,000 bounties. The first one is $3,000. The second one is $2,000, and the third is $1,000. And this is like an overall best dApp built on top of Cello. Then we have two more themed bounties. The first one is best mobile dApp on Cello, that's $2,000, and best use of account abstraction or social connect. So my friend Harpal will talk more about these two bounties. So yeah, let's call him.
So yeah, that was about Cello, but now we're going to talk about something on what you can build on Cello, right? So more elaborating about the bounties. So one of the things that you can do for the best mobile dApp or like best dApp overall on Cello is build on MiniPay. And MiniPay is this very simplified Web3 wallet built in the Android Opera Mini app. So it's so simple that the users already have the Opera Mini browser, and there are so many people who have the Opera Mini browser. all they have to do is just go into a menu option and they will be able to use MiniPay inside the wallet. So what I'm trying to emphasize here is that MiniPay has, like Opera Mini has so many users. There are already so many downloads, like 500 million plus downloads and over 100 million active users. So you could imagine if your app goes live inside MiniPay, then everybody will have access to it right away. So imagine your app being live inside MiniPay, right? And what are some use cases and what are some app ideas that you can build in this hackathon? One of them could be personal finance apps, apps which allow budgeting, income, expenditure type of apps, stablecoin yield type of apps. You could build apps which allow transacting with merchants or makes it easy to do B2B transactions. You could build apps which are earned type of apps, like move to earn, like run to earn, all those earn type of apps. You can build a billing type of apps, like apps where people can see analytics about the payments, when they received it, like see analytics graphs, who the users are, what is their average payment that they are receiving, etc. And also like NFT viewers or any apps which are like NFT utility apps that you can also build inside MiniPay. These are not available right now, so there's a chance that you can build it and it might actually make it to the MiniPay app. The other apps which can be gift cards, coupons, you can also build like a Grab, like super app, micro work marketplace. This is something which has been requested, so it's a hot app that you can build during the hackathon. Asset tracking accounting, I just mentioned it. So yeah, these are some use cases and ideas that you can build right in this hackathon on MiniPay, and you can be eligible for like 4 tracks, like 4 bounties. So yeah, go for it. Some tips about when building on MiniPay. MiniPay automatically connects to your app, so like there is no connect wallet button, right? You don't have to build a connect wallet button in your app. It automatically connects to your app. And the way you identify that your user is coming via MiniPay is via this variable called window.ethereum.isMiniPay. If this is true, then your user is using MiniPay, and you can accordingly tailor your experience for that user. Our guideline is that aim for like very simple UI UX. Don't assume too many things. Assume that the user knows nothing about crypto and build your app accordingly. Recently, between the 2 hackathons, Istanbul and India, we introduced developer mode. So if you go to settings and you tap your version number 10 times, you will be able to enable testnet. So you don't have to like come to us for mainnet tokens. But if you want to build a dApp on mainnet, come to a booth and yeah, we will provision you. So this is a QR code that you can scan. If you scan this QR code, you will go directly to a page where you have all the information you need to build on MiniPay. And I recommend everybody to keep their cameras on. There are a lot of QR codes. So yeah, keep your phones up. And the second thing that you can build during this hackathon to be eligible for the mobile app bounty is Valora hooks. So I can talk more about what Valora is. Valora is a mobile crypto wallet which leverages a lot of features that are available in the Celo ecosystem. For example, sending tokens to phone numbers and like paying gas with stable coins. So yeah, those are some features which are natively available in Celo, and Valora leverages many of them. But what we are trying to emphasize here in the hackathon is that Valora introduced this new feature called hooks, which is a plugin system where users can install small plugins in the wallet itself to have a very native experience, and I will show you an example of how it looks like. So this is how a typical wallet screen looks like. You see your assets, you see the change in prices, and also the amount that a user has. But what Valora allows is that you can build a hook which allows the wallet to keep track of their dApp positions. So what I'm trying to say is that if you have used a wallet, you will have noticed that let's say you have to go to Uniswap and see how much I'm earning on my yield, how much stake I've done, all of that. What if the wallet could detect that, and like somebody could build a plugin and you see that information right inside the wallet. This way you are like protecting your user from getting phished, because they don't end up on different websites or like clones of websites. So they can get this information right in the wallet interface rather than going to browser and going to a link, etc. So this is the dApp position type of hook. Then we also have shortcut hooks, which is claiming rewards and any type of actions that a user would need to do by going inside a browser, visiting a link, and like going through loops. So they can do it right here just by clicking one button, right? You can create shortcut hooks for that. So yeah, it's basically a short program that is installed by a user, which is built by a developer, and Valora calls this hooks based on in-app events or blockchain events. So you can leverage all of that in your hook code, and accordingly the hook will play with the user. Like the user can play around with the hook. What is the current state? What type of hooks can you build? You can build DeFi position hooks. You can build shortcut hooks, name resolution hooks as well. So yeah, give it a try. And here are some ideas for things to build using Valora hooks. You can build hooks for claiming curve rewards, because that's not available right now. So something you can build. Hooks to like liquid staking on Celo, to like get information about it, claiming rewards, etc. So yeah, and Ethica bonds as well. These are QR codes for docs. The left one is for docs, and the right one is examples on the existing hooks inside Valora. So you can just go there, copy the code, paste it, edit it, and like do your thing, right? So Social Connect. What is Social Connect, right? Before we understand what Social Connect is, let's understand why Social Connect exists. And this is basically my wallet address. This is my public wallet address. And to be honest, even I don't remember what my address is. And I don't expect anyone to. But imagine your daily life. Like when you want to send transactions to any of your friend, you know their phone number, or you already have it in your contact book, and you just have to tap on their face in an app, and you can just send them money, right? That's not the experience that we have here in Web3. And we obviously can't remember our own wallet address. So there's no way we are going to remember our friends and family's wallet address. So yeah, imagine you have to memorize Ethereum addresses for all the people in your contacts. You can do it if you are a memory champion. Other than that, there is no way to actually achieve it. And the other thing is, there is ENS. You have to pay for it. You have to buy it, and you also have to pay a recurring fee for it. You have to make sure that nobody else takes it someday. And even if, like in the Web2 world, there are so many identifiers, right? Like there's Gmail, Twitter, LinkedIn, Discord, Telegram, ENS, and Facebook, and even Threads, right? I don't even use Facebook at this point, but there are some people who do it. What if we as a protocol can provide this feature where the user can decide which identifier they want to use to get identified by, right? And this is where Social Connect comes into play, right? This is what Social Connect is basically. You let the user specify which identifier they want to use and tell everyone that this is how you identify me on blockchain, right? And this is already live in many apps, including MiniPay, Libera, and Kala Wallet. What it allows is that you can basically put in your phone number, and it will recognize who you are on chain, and people can send you tokens on chain. And if you scan this QR code, this is a cheat sheet on how to build on Social Connect. So yeah, highly recommend. This will make you eligible for the $2,000 bounty. So yeah, highly recommend checking it out. And if you have any questions, come to the booth. So that was about Social Connect, but like what to build on Social Connect, right? You can build issuers. You can you can become an issuer where you can let users identify themselves using identifier which you define. It could be UPI, right? You can be an issuer for UPI. You verify people on using their UPI ID, and then you can let them identify themselves on chain using UPI ID. You can also integrate Social Connect in existing dApps which don't support it. That's also something that you can do. You can add support for, let's say, GitHub on an app where people can just sign in with GitHub, and then they can send and do transactions with GitHub usernames. Or you can build something for interoperability. Many wallets that are using Social Connect, they don't work with each other. Social Connect does not work with each other in those wallets, but the protocol is built for composability. So one wallet can discover users registered on other wallets as well. So why not leverage it, right? Nobody is doing it. So I hope someone here in the audience or here in the hackathon would do it, right? Because there is this gap that you can build for. So that was about social connect. And now we can talk about account abstraction, which is also one of the concepts or like things that you can build and be eligible for bounties. So for account abstraction, you can use third web SDKs. They have custom factory, custom accounts, and yeah, the thing about vulnerability, anything happened after 22 November is okay. So we are obviously after that. So if you deploy any custom account factories, accounts, they will all be safe on the third web SDK dashboard, and also transaction batching is supported. So if you scan this QR code, you will get a guide on how to build account abstraction dApps using third web. And then there is also other options like Pimlico Bundler. Pimlico Bundler is live on Cello. You can use it for mainnet, testnet. There are also paymasters live. So if you're building something using Pimlico, just wanted to let you know that it works on Cello as well. And then there is Candid as well. So if you are somehow using Candid Bundler, they are also supported on Cello, mainnet, testnet, and also there are token paymasters by Candid as well. So go use it. And there's also this QR code. If you scan this QR code, there are more ideas and more like all the instructions on how to use Candid for building account abstraction dApps on Cello. But here are some ideas from us, like what are we looking for? What is something that we expect a hacker would build related to account abstraction? You can build like social connect based recovery accounts, right? Since social connect is already a protocol where people are identifying themselves using Twitter, GitHub, Facebook, whatever, why not allow users to recover their wallets using social connect, right? You can build family accounts where there are multiple owners with different limits. So like parents can have parental guard on the account and say like my child or son or daughter can just use $20 or $30 a day. You can create such accounts using account abstraction. You can also create accounts with transaction validation using fingerprints, Face ID. All these smart contracts and validation code is available open source for you to build. So look out for it. You can also create accounts which are based on session keys for gaming, social media, so that the user does not get recurring pop-ups like confirm this thing, confirm this transaction again and again. You just make the user confirm once, and then maybe you ask after 30 minutes or 60 minutes, something like that. You can also create a dead man switch module. This is where, let's say you have a crypto wallet and nobody else knows about it, and for some bad reason you are not alive anymore. How can someone recover your wallet, right? How can someone recover your wallet? So maybe think more about this situation, because this is a real use case that you could build for. Then there are custom paymasters also that you can build. If you're not into building accounts, you can build paymasters for tokens like Good Dollar or staking reward tokens, or you can even build paymasters which are based on referrals. So like the more people refer, they get more free transactions on a dApp. And finally, you can also build app-specific paymasters as well, like paymasters who only let people do transactions on a specific app and reject for other apps. And use Cello Composer. So what is Cello Composer? Cello Composer is this template that we have created specifically for hackers. You just run one command and you will have everything set up. You don't have to waste time figuring out how to use RainbowKit, how to use Wallet Connect, all of that. We have figured it all out and made it open source for you. You just run this command, you select which framework you want to use, React, React Native, without Expo, Angular, Flutter, whatever you want to use, just select the options and you will have the code ready for you. Then you can just work on your actually building the dApp and not figuring out the basic Wallet Connect stuff. And this is also a QR code again, where you can scan this. There are steps on how to build account abstraction dApps using Cello Composer. So you download you install Cello Composer, like you get the open source code, and what can you do next in order to like build account abstraction dApps. And then there are many other partners who are in the Cello Web3 ecosystem as well, like Safe, MetaMask, Chainlink, Graph. You are doing bounties, and we know that you're going to stack bounties. So these are the people, or these are the projects that you might want to build on, or like build something which is close to their bounties, and you can like stack bounties for the hackathon as well. So a little bit about the judging criteria. For the theme bounties, on MiniPay, you can build on mainnet. You can also build on testnet. For account abstraction, it's okay if you're building on testnet as well. And if you're building like a project which requires smart contracts, like deploy those contracts on Cello and mention those smart contract addresses in your GitHub README. And we will have multiple queues for live judging. So for everyone who was wondering like how will we demo, there will be multiple queues. So everybody will get a fair chance to like demo their project. And faucets, go to faucet.cello.org. And if you want mainnet tokens, come to our booth and we will be happy to provide you. Everything in one place. If you just scan this QR code, if you missed any of the previous QR code, you just scan this and you will have all the information you need. Bounties, important links, judging criteria, ideas, everything in one place. And again, bounties, first place, second place, third place. First place $3,000, second place $2,000, third place $1,000, and 2 theme bounties, one for mobile app, which is mobile app, which is $2,000, and for account abstraction and social connect, $2,000 again. And these are the faces you want to remember. Me and Viral are here, Eric, Daniel, and Jason. These are 5 faces that you can. Don't hesitate to ask help from any of these faces. We'll always be available at the Cello booth as well. So come to us, ask for any help you want. If we are not available at the booth, go to Cello sponsor channel in ETH Global Discord, and you can ask questions there as well. We are keeping an eye there. And that's it from me. Thank you guys for your attention. And yeah, build on Cello.
Break. We'll be starting again at 6 o'clock. We have a great talk from Scroll at 6, but we are going to take a 20-minute break. So why don't we take advantage of the opportunity? And if anyone wants to come forward and ask a question with Viral and our buddies,
sure.
we're happy to take that time.
If anybody has questions, please raise your hands. Cool. Yeah, go for it.
Hi.
Yeah.
So we are building another live location-based reward. So we are building as a travel experience app. So where you go, where you discover a place, and you upload in our platform. So people who again take that place in our platform, they can able to get rewards. So but they need to prove their location on the time, like real-time location-based.
Right.
So we are using, we don't want to take the user's location, but we want to prove that they are there on the location.
Oh, I see.
So that's what the
I see. Yeah, I haven't come across any such solutions where you can like prove you are at a location using zero knowledge, but I would say try it. Like maybe do something, maybe the places which they are providing the experience review for, maybe they have something, the place itself has something which can like basically something like POAP maybe, like it's a proof of attendance thing, right? It's a proof of attendance that you are here at the event. Maybe something similar for the places. They have something similar to POAP which the user has to like get like mint or maybe interact with in order to prove that they actually were at that location. Maybe you can use something similar to that.
Yeah, proof of attendance could be like for the events, but what other if you went to the cafe or if you went to the temples or like that?
Yeah, even temples and cafes can have it as well. I mean, the name is proof of attendance, but it can be that you actually went to that place as well. People are also doing POAPs for if they meet in person, so it can be used for anything.
What do you mean by meet apps?
No, like let's say I meet you and you want to prove that you met me here in this event. Maybe I can have a POAP which says that everybody who met me has minted this POAP because I interacted with you or I gave you the link to mint that POAP when you actually meet me.
Okay.
Yeah.
Thank you.
Cool. Any more questions? Cool. Yeah, I think we don't have more questions. Thank you everyone for being here.
Hello, thank you everyone for joining the Scroll workshop. Just as a heads up, this is kind of a beginner level workshop for really introducing the idea of what a layer 2 is, what a rollup is, and how to really get started with Scroll deploying contracts, and hopefully just better understanding what Ethereum needs to do to scale and how to scale securely. I'm Daniel Helm. I lead the developer relations team at Scroll. If you want to find me on any socials, anything else, DG Helm down in here in the corner. So agenda, we're going to talk about Ethereum having a scaling problem. We're going to talk about what Scroll is building to kind of solve that. We're going to talk about deploying your contracts on Scroll, and then of course prizes, additional info relative to the hackathon. But I'm going to leave this up here for a while. I will show it again at the end of the talk. It is a QR code to get you in a Telegram group for hackers. We also have a faucet bot in here, so you are able to show up, say drop your address, and you'll get some Scroll Sepolia ETH to get started hacking, which is the first step. So, all right, so let's talk about Scroll. If you show up on the Scroll website, you've never heard of us, you're going to see that we're seamlessly extending Ethereum's capabilities with zero-knowledge tech and EVM compatibility, an L2 network, devs, Scroll, bridge, a lot of jargon, right? You see this, you don't understand what some of these things mean, it might make you feel a little bit like this. But if you walk away with one piece of knowledge from today's talk, is that for users and devs, Scroll is pretty much Ethereum, right? Like the experience, pretty much Ethereum. And I'm going to show you quickly what that looks like. We have a clone here of Uniswap, and we can see that I'm logged in with my wallet, and I can get in here and grab some Go, swap that for Ethereum, see what my best price is here. Great. We're going to swap this thing. And if you've used Uniswap before, this should be a similar experience, right? Your MetaMask pops up, you confirm the transaction, you've done your swap, and instead of waiting 12 seconds for an Ethereum block, you wait 3 seconds for a Scroll block. So that's the idea of what it looks like to use the ZK EVM. Let's get into talking about like what it actually is, though, why we're building it. And yeah, so anything you're using on Scroll, like all these projects that are deployed either to our testnet or our mainnet, which came out about a month and a half, 2 months ago, should all have this similar level of experience for you. But let's talk about blockchain scalability. We are all here because of the beautiful promise of Ethereum. We are a platform for decentralized application. It's a single network where you share code and data, you create all these new possibilities. It's open to all and anyone can join in. Just not too many people at once, right? If too many people try to use Scroll at the same time, you see a situation like this. You go to mint your NFT, swap your token, and it asks you to pay $132 in gas fees, right? This is a mess. This is not accessible. This is not the Ethereum that we want. What's happening here? Well, if you're unfamiliar, we have this idea of an Ethereum block, and what we're doing is we're sending a transaction, and we're asking the network to do some work, and that's measured in gas. Each block can only do so much of this work, and so the block, or the person creating the block, is going to pick those transactions that are going to pay them the most to do that work, who are paying the highest gas price. And this is the idea of block space, and once that block space fills up, once a block is full, it becomes an auction and the price goes up, right? There's a lot of hand waving here, but that's the general sense. Okay, so we have a problem, we're engineers, we say, let's make a better system then, right? So let's put our protocol designer hats on. I think the first thing anyone wants to say in this situation, yeah, this is easy to solve. We just make the chain do more work, right? Just make Ethereum do more work. Well, let's remember how Ethereum works, right? We have this decentralized network, and we can imagine each one of these dots as nodes in that network, right? As a transaction comes through, every single one of these one of these nodes has to do the work of that block, right? They have to verify what a transaction does and redo that work on the network. So what we're actually saying when we say make the chain do more work is make every single node do more work, right? And for some nodes, supercomputers with 10 gigabit Ethernet cables, they're going to say, yeah, I can do more work. This is no big deal. But for maybe resource-constrained, smaller PCs, people running things at home, they're going to get priced out, resourced out if we just try to keep cranking up the constraints or the requirements it takes to run a node. And what happens is our happy, healthy graph that looks like this gets a lot of people priced out, which makes it more vulnerable to bad actors, right? We don't want that. What we're doing there is we are sacrificing decentralization. And this is one aspect of what gets labeled as the scalability trilemma. And the idea of that is that when you design a blockchain, you get to pick 2 of 3 things: scalability, security, decentralization, right? And so in this situation, we've cranked up the requirements for our nodes, and this is typical of high TPS chains. We have sacrificed decentralization for scalability and have maintained some level of security. So, solution 2 of our protocol designer, right? Okay, we can't make the chain do more work, but what if we just made a new network, right? So now we have our graph, and we just say like, all right, let's cut a line down the middle. We'll take all the nodes and validators from one network. We'll still call it Ethereum, and then we'll make another one, Ethereum Prime. And so now we have 2 networks. We've doubled up the amount of work that we can do without increasing the network requirements. But there's an issue here too, right? Now we have half as many validators putting up stake, half as much security there, not to mention we have to figure out how to bridge the gap of this black line, which is a non-trivial problem. And this is the idea of maybe the multi-chain ecosystems that sacrifice on security, they maintain their decentralization, and they scale this way, but it's still not ideal. So part 2 of this story is when we come in and save the day with L2s and rollups. As we mentioned, Ethereum is this network of nodes doing a bunch of work, and we're going to symbolize that as a big block here. So I have very mature graphics. Thank you. We can think about this work as the block, and we can break it into sub-work, right? So maybe this top block up here is minting an NFT. Maybe this is swapping our token. These are things that smart contracts do on Ethereum, right? Now, thought experiment. What if we just dedicated a piece of the work that Ethereum was doing, and we just dedicated that to making sure that a different network was not breaking its rules, that something off-chain was not lying, cheating, or stealing, and a smart contract was able to consistently verify that? Well, this is the idea of securing an off-chain protocol using Ethereum. So a layer 2 exists as its own off-chain protocol using a layer 1 as an important piece of its architecture. And we say that it is deployed on top of it. Now, rollups specifically use L1s to have certain security guarantees here from Ethereum, right? We have to like really constrain some of these things. And so we have things like ordering, data availability, censorship resistance, state transition correctness. Like a rollup has to inherit all of these things to be truly secured and know that we're not lying, cheating, and stealing as a protocol. And rollups on Ethereum, we say that they inherit the security of Ethereum. The idea here is that when you use a rollup like Scroll, there are no additional trust assumptions beyond the trust assumptions you make of Ethereum. And this is a little bit of a bastardization of the trilemma here, but we can imagine this as Ethereum really locking down the security side of this triangle. And so we can say now, okay, we've got security locked down. Well, now let's make a new network, an off-chain protocol. Let's crank up the constraints of it, the resources of it. We'll make the chain do more work. And through that, we can become more scalable while still building on top of traditional chains that are highly secure and highly decentralized. And this is my wonderful graphics about L1s and L2s. There are a lot of L2s in the marketplace. You've probably heard of a lot of these. And there they are listed on a wonderful site called L2Beat. But coming back to our like protocol design game, right? We've said, okay, we're going to make a rollup. This is good, but like the rollup could do anything, right? We're just using Ethereum for the security, but our rollup could do whatever we want. Well, let's look at maybe Scroll's biases here. We look at the situation, we say, Ethereum already has this incredible ecosystem, right? You're here, part of the ecosystem, and it also has all these tech parts of its ecosystem. It's got great tools, educational resources, wonderful users and communities, and smart contracts that are ready to deploy. So we're already inheriting Ethereum's security. Why not also just inherit all of this from Ethereum? And so as a choice, we can say, wherever we can, let's just behave exactly like Ethereum's virtual machine, that thing that does the work on the network, so developers don't have to change their mindsets, learn new gotchas, or anything else. And that is kind of the basis and the idea of Scroll, thinking about how to scale Ethereum in a reliable way without being a bad developer experience. So coming back to this model, we can see that still we have this idea of, Ethereum doing work, making sure that a new protocol is not breaking its rules. Let's look at different ways you can do that. So on the bottom here, we have what we call optimistic rollups. And what they do is they say, here's all the transactions that came into my chain, Ethereum layer 1, let me show them to you, and I'll just show them to you. We'll sit and wait for 7 days and see if anyone raises their hand and says, no, this is not how things are supposed to work. We call this fraud proofs, and it's this like economic incentive, this game where you expect there to be one honest actor that's going to like say, no, the chain over here, the off-chain protocol is lying, cheating, or stealing. Now, Scroll takes a different approach, right? What we do is we put all that data on chain, and for something that we call a ZK rollup, right? We are not an optimistic rollup, we're a ZK rollup. And unfortunately, this means I now have to talk about zero knowledge. So let's get into part 3, zero knowledge proofs. All right. Is everyone still with me? We're going fast. All right, zero knowledge proofs. Here we go. Let's do another thought experiment. We've got a lot of work. We've got some input or data that we're going to put into this work. And it is a lot of work. It takes a whole host of supercomputers that we don't really trust to do this work, and it takes days, right? Now we can imagine we have a magic wand, and out of that work, we can have a receipt for the work, right? And the receipt for the output of that work can be verified by one of these really simple computers. And that simple computer doesn't have to go back and redo all the work of the supercomputers. It can just verify the proof cryptographically and say, nope, I know, I can guarantee that all this work was done correctly, right? This sounds kind of magical. It sounds like you need to get in a time machine for something like this to exist, and we do, and it's back to 1991 when we had papers and constructions coming out like checking computation in polylogarithmic time. This paper has this like funny little line where it says, in this setup, a single reliable PC can monitor the operation of a herd of supercomputers working with possibly extremely powerful but unreliable software and untested hardware. We do not trust the supercomputer, but we can still monitor and verify its output. Okay, so back to our imagination scene here. Let's kind of like specify what this work could be. What if the work being done was the EVM, the Ethereum virtual machine, right? And it was doing work over incoming transactions. And instead of supercomputer, we have a really powerful blockchain network called Scroll, right? It's got a lot of resource requirements, but that's okay because it will output a proof, and that proof won't be verified by a Raspberry Pi, but instead by Ethereum smart contracts, right? That little bit of work on Ethereum is able to verify all of the work of a second Ethereum doing more work than Ethereum itself using zero-knowledge cryptography, and it can verify those proofs. So that is the idea of Scroll. We are a ZK rollup, and that thing on-chain on Ethereum is a ZK EVM proof verifier, right? Is sitting there constantly about every 20 minutes getting a new set of proofs over the transactions that come in order to secure Scroll and to make Scroll something that can be scaling Ethereum. I won't get too deep into the transaction lifecycle and everything else like that. If you want to talk about it, see us at the booth. But the idea here is that we can have a whole lot of blocks coming in every 3 seconds, commit a chunk of that to Ethereum, and then later on kick off, GPUs producing proofs, and then those can commit those to Ethereum as well. So Ethereum's got all the incoming transactions that came into Scroll. It also has a proof that our state transition was done correctly. So why build on Scroll for this hackathon? Well, it's got great developer experience. We are bytecode equivalent with the EVM, which means that all your favorite tooling, all your favorite tutorials, open source contracts are good to go, right? You can copy, we have this phrase, copy, paste, deploy that you might see around, and that's the idea. You don't have to have any like hidden gotchas as you're building with Scroll. It's got higher throughput, it's got lower gas fees, and your users are going to get quicker feedback because we've got 3-second block times relative to Ethereum's 12-second. And lastly, I think Maybe this is a term that gets maligned a little bit, but I think alignment here is pretty interesting. Like, we are here not to just scale Ethereum the technology, but we take it seriously to also try to scale Ethereum as an ecosystem, Ethereum as a culture. Originally, Scroll, its origin story was it was built as an open source project in collaboration with the Ethereum Foundation's privacy and scaling explorations team. And so really building that out is, I think, core to our DNA. So, done a lot of talking. I think we'll have plenty of time to maybe ask questions about Scroll, but let's see what it looks like to deploy using Scroll. So let's go to Open Zeppelin's ERC20 contract and go ahead and just copy this. You can Google search for something like this. And if you're not familiar, there's a tool called Remix that the URL is probably too small to see, but it says remix.ethereum.org. And it's a nice browser-based way to test out smart contracts and deploy them. But let's make a new contract here, and we'll call this token.sol. And I will paste my ERC20. My guess is when I go to compile this, it's going to want a newer version. I think it does. So it wants me to try out 8.22. Oops. But now let's see if I can compile this. There we go. It's happy enough. I've compiled my contract. What does it look like to deploy it on Scroll? Well, as long as you have your MetaMask set up for the Scroll network, you can go to Injected Provider MetaMask. It will recognize the correct network in your current account, and I can put my initial constructor amount, so let's just say that, and I will deploy. Now we see we're creating the token. It asks to deploy, put in a really high gas price, but shrug. Give it a few seconds here, and now we are deployed. And we can see that down here, I have a contract address, and I can go to sepolia.scrollscan.com. And check out the contract that we just deployed on Scroll 24 seconds ago. Okay, well, a lot of you are not going to be using Remix to deploy. So let's take a look at what this looks like using Foundry. If you're interested, I think the best way to kind of get started using Foundry, Hardhat, other traditional dev tools is to check out our docs at docs.scroll.io. And we have actually quick start links down there, but down in the developer section, we have a developer quick start. And here it goes through how to acquire Ether, how to set up your network configurations for both mainnet and testnet, and then the configurations for setting up Hardhat and Foundry. But I'm too lazy to look at the docs. I like cheat sheets. And so instead, I'm going to go to something that we put together for ETHIndia, which is called ethindia.scroll.systems. There's also a QR code on the postcards that we have on our booth. And it tells you all about some of the things going on. There's a cheat sheet right here. And it also has wonderful information about verifying contracts and settings for things like Forge, things like Foundry, and things like Hardhat, rather. So let's follow along with these a little bit. I think I could go to showing how to use this with Forge. I could say Forge init, and I'll say ETHIndia live demo. And I will create a new Forge project here. Wonderful. Now I will CD into that. And let's open up our code here. Close out the other one, sorry. Okay, this is very zoomed in. But when you init a new Forge project, it actually comes with a .sol file. You can put whatever you need to in there, but we'll just start with the default one. But we want to go into this foundry.toml file and modify our configuration just a little bit so that it knows about Scroll and Scroll Sepolia and how to verify contracts using them. So I'm going to copy paste these RPC endpoints in this Etherscan configuration, place it here in my foundry.toml file, and save. And so now I should be able to write forge create We're going to compile and deploy the counter contract. For our RPC URL, we just set one up for a label of scroll Sepolia in that configuration file. We want to verify this on scroll scan, because that's part of getting your nice little bounty. And we'll also provide a private key, which I believe goes like this. And I have set an environmental variable, so you can't get my private key like that. Oh, nice try. Let's try it again. Okay, there we go. Now we've compiled, and it's saying nothing is there. So let me go ahead and do this. Huh. Live demo fun. Okay, let me go ahead and just try one more Forge init and try another one here saying rough demo. And then I can open up this. And again, I want to take that information in my foundry.toml file to set my configurations. And I'm going to just try and run that same command as before, forge create counter with our RPC URL. And it helps if you have a space after scroll Sepolia. It's probably my issue. So now we've actually compiled it. And we can see that it interacted with Etherscan. And because it's actually already seen this contract, because I've verified it before we even verified it, it knew what this contract was. But we could go ahead and modify it if we needed to, and it wouldn't know what it was at that point. So now we've modified that a little bit. Let's make sure we can actually verify on scroll Sepolia. And it's doing its best now. So let me grab this, and we will open that up back in sepolia.scrollscan.com. And we can see that this contract has been verified, and our modified code is viewable here. And that's it. So that is deploying on Scroll. Should work seamlessly out of the box with all your favorite dev tooling, any tutorials, demos that you're used to. So again, we have a hacker Telegram group. I'd encourage you to scan that QR code, ask for help here or in the Discord. You can also get your Sepolia testnet ETH, your Scroll Sepolia testnet ETH, by following the example of other people for how to grab it. And again, we have that cheat sheet, and not only has information on deploying and verifying, but also has information on every other kind of partner here at ETH Global that is deployed on Scroll Sepolia. So if you want to both deploy on Scroll and Safe, you can use those things together by grabbing the contract addresses there. That is ethindia.scroll.systems. Now for the prizes, if you are engaging with this side of things, we have two categories. So one, I just demoed how to deploy and verify a contract on Scroll. That would have put me in the $7,000 prize pool for doing that work. If you are a newcomer to the space, we welcome you. Get something deployed, build something this weekend. If you are building something maybe a little bit more complex, advanced, you might want to apply for our Best on Scroll prize. And we will have 10 $1,000 winners for folks that complete this, build something on Scroll that we think is fun, innovative, weird, whatever. We really like things that people are passionate about, and we'll have 10 of those winners for $1,000. So I think that's it for me, but hopefully I left enough time for questions as well. So, cool. See if I can mount, like read lips.
Check one. All right, let's get some questions.
Do we have a documentation for how to integrate Safe with Scroll?
I can't actually hear you. I heard the word documentation. Oh, safe. Yeah, absolutely. So let me pull up that cheat sheet again. Again, this is ethindia.scroll.systems. It's actually /cheat sheet, but there's a link at the top of that. And you can see ETHIndia partner integrations. We can go to Safe. And you'll see that we have a site that is like a front end for Safe if you want to use that on Scroll or Scroll Sepolia. You can check out their docs. You can see kind of a demo using AA AuthKit. You have their factories, their Safe Core protocol, contract addresses, and their transaction service API. So I think that should be everything you need to get going there.
Any other questions? Raise your hand. Why don't you come up front so we can hear you better? It's always a good workshop when Daniel Helm's at the helm. Anyone else have questions? Why don't you come here so we can hear you better?
I think there's no questions.
Anyone? Raise your hand. I can also come to you if you're shy. And repeat the question. Any questions? All right.
All right.
Well, let's rock and scroll.
Thank you so
Daniel.
much, everyone. Come see us at our booth. Thank you very much.
All right.
Hey everyone. So thanks for coming for this workshop. In this workshop, I'll very quickly show you how you can get started with ZK EVM, how you can build your projects on ZK EVM. But first of all, GM, or I should say ZM, because we are moving into this world of ZK, right? So what is Polygon ZK EVM? So Polygon ZK EVM is an EVM equivalent ZK rollup. It harnesses the power of ZK to reduce the transaction cost and increase the throughput. And why Polygon ZK EVM? We feel that it's the next chapter of Ethereum scaling. So it's very exciting for developers because you can use all the same tools and technologies that you have been familiar with, like different wallets, like tools for developing smart contracts like Foundry, Hardart. You can code in Solidity. So it works pretty seamlessly. They all work out of the box. Just I need to highlight that the only thing is that that I want to call out is that we don't support 3 pre-compile opcodes. So if you're building on that, just be aware. Otherwise, everything works pretty seamlessly, which is very great for a dev. So first half of ZK EVM is ZK. I'll explain this with an example. So everyone must have played this game called Where is Waldo in their childhood. Basically, it's kind of a puzzle, and you want to find out, like you need to figure out where Waldo exactly is, right? So, so what if I say I know the location of Waldo, but I can prove to you without actually revealing the actual location of it? How am I going to do it? So I'm going to take a big piece of black paper. I'll cut out the shape of Waldo and I'll place it over the picture. So in this way, I can prove to you the exact location of Waldo, but I could have placed the puzzle in any of the corners or anywhere around the black paper. So in this way, you don't know what's the location. Only I know, but I have proved to you that I know the location. So this is technically how ZK works, right? So in real life, ZK works with complex maths and cryptography to prove a validity of a statement without actually revealing that statement. So we have talked about zero knowledge, but what exactly is a rollup? So zero knowledge rollups are layer 2 scaling solutions that increase the throughput, basically they scale Ethereum by increasing the throughput and reducing the transaction cost. Yeah, so in case of a ZK rollup, ZK EVM rollup, so ZK EVM rollup is technically a ZK rollup that is designed to mimic the same transaction execution environment as mainnet Ethereum or Polygon POS or any other EVM chain. So what's the benefits and features? So it inherits the Ethereum's battle-tested security. So the proof is being posted on Ethereum, and Ethereum has been running successfully for years, right? So we trust it. We love it for DeFi. It's scalable. We achieve this scalability by batching many transactions together to unlock higher performance, right? And obviously it brings down the cost gradually low, and it's EVM equivalent. So the benefit, as I explained before, is that you can use all the tools out of the box. So I'll quickly explain the architecture of Polygon ZK EVM. So think about this as a transaction lifecycle. So we'll get into a small journey from where a transaction is sent by a user till this transaction is completely final on Ethereum, right? So we start by receiving this transaction on the node sent by a wallet or any script based if you are working on a project. So this transaction goes to a pending transaction pool, and at some point, the sequencer, you can see there, the top, like right, it's part of the node. It picks up the transactions, it executes these transactions, and then puts them into an order. So this ordering is actually what we call as the trusted state. It's trusted because it's not yet on layer 1. And the sequencer essentially just says that, hey, this transaction will be included in this block. This info is then can be shared to the other nodes in the network by the broadcasting service, and this information can be shared to the users as well. So this is this is where we actually achieve the first level of finality or first level of confirmation, right? Then after a certain time, the sequencer have when it has accumulated enough transactions in the trusted state, it'll send these transactions in a batch to layer 1. It sends it to the rollup contract that's called as polygon zkavm.sol, to be precise. So you can see the contract there. So the main goal of this interaction is to put the DA, the data availability, on Ethereum. Basically the data of the transactions to Ethereum. After we have done that, the key point is that any node in the network can then read this Ethereum smart contract and rebuild the state using this info. And we can rely on the data that is posted on Ethereum, because what's on Ethereum, it will stay there for long enough, we hope, right? And now because of this, we can rely on the state of layer 2 rollup as it's on Ethereum, right? It is what we call as virtual state. Now here we realize that we haven't talked much about ZK, right? It's ZK EVM. So here's the thing. Although we have this data on Ethereum, but like the Ethereum smart contract doesn't understand the processing of these transactions. It just knows that there's bunch of data, and in order to make it aware of the latest state of layer 2, it's when we need the ZK proof. There is another role in the node called aggregator, which will fetch this data and generate a ZK proof after talking to another service called prover, and say, hey, after processing this data, the state of the network is this, and of course we compress this state into a hash, a Merkle root to be precise, and then submit this ZK proof to Ethereum. This state is called consolidated state, and that's how we are scaling transaction while we are inheriting the security of Ethereum. So these are the three stages of finality that I talked before: the trusted, virtual, and consolidated. So it's the trusted state where the batch generation and the broadcast happens to the L2 node, and it's basically given by the trusted sequencer. Then we have the virtual state where we are putting the data availability onto Ethereum, and then we have the consolidated state where we are generating the proof and we are actually putting this proof on Ethereum. So yeah, some of the industry use cases and things that we are really excited you all will be building this weekend are DeFi and in TradeFi space when you are transferring value. So like when you are transferring value, you want high levels of security. So for finance, we highly suggest using ZK EVM. Even like in other use cases like healthcare, gaming, supply chain, you need high level of trust. We highly recommend using Polygon ZK EVM when you are figuring out what chain to go for. So to get started with building with Polygon, you first need to bridge some funds from Ethereum, and technically you need to bridge Ether from Ethereum to get ZK EVM ETH that you can use to submit transactions, pay for gas fees, etc. Right? So you can do that by going to wallet.polygon.technology. There you can just select based on if you want to go for testnet or mainnet. You can select the network, you can select Ethereum, and then basically you can just click the button start bridging, and you will have zkAVM ETH in your wallet. So for mainnet, it's obviously you need to bridge over the real ETH, but for testnet, what else you can do is go to faucet.polygon.technology, paste your wallet address there, and click Polygon zkAVM there, the network, and you'll receive zkAVM ETH. Yeah, so as you can see, it's very simple to deploy and get started with zkAVM, and swapping your development environment from Ethereum or any other EVM chain that you're using to Polygon zkAVM. And this can happen just by changing one line, that is basically changing the JSON RPC. So that's really what you need to do. So I'll just show you how we can do this very quickly using Hardhat. So I'll just jump to VS Code. So this is a very basic project of Hardhat, and I have a contract here called greeter.sol that you get out of the box with Hardhat. So in this contract, you can see we have the pragma statement. Then we have a constructor function. We have a view function that is greet to actually see the value of greeting that we have defined here. So the contract is maintaining the state of this particular variable. We can use this function to get the value of greeting. We can use the set greeting function here to actually see what is the current value of greeting, and we have this constructor function to set the initial value for greeting. Then I've written this small deploy.js script. This is to actually deploy this contract. So I'm using this dependency called Hardhat ethers, and I'm calling this deploy contract method to create an instance of the contract and then deploying it. Then I'm just printing the address for the contract that I've deployed, right? So what I was mentioning was that how you can just deploy on Polygon. You just need to change one line of code, right? So it's this simple line of code that I was referring to. That's the JSON RPC. So in the network, this is the config file, right? So in the I've named the network as zkAVM. I'm mentioning the URL, and I'm also mentioning what my private key is so that to make Hardhat aware of from what account I want to deploy my contract from, right? So I've put the value for this in my .env file. So if you just want to deploy this contract, what you can do is say npx hardhat run, and I want to run this particular deploy.js file. So I'll just say scripts. It's in scripts folder. Say deploy.js, and I'll just select the network, which is in this case is zkAVM. And I'll just hit enter. Yeah, as you can see, the contract, I'll just move this up a little bit. So as you can see, the contract is deployed to this particular address. We can go and have a look as well. So for that, we have the explorer at zkavm.polygon.technology. zkavm.polygonscan.com. And for testnet, it's testnet-zkavm.polygon.com. So right now, as I've deployed it on testnet, I've just copied the address. I'll just paste it here. As you can see, it was deployed 1 minute ago. So I was able to do it because I had some funds in my wallet. But for you to get it, again, you can just go to wallet.polygon.technology to bridge over the ETH or you can go to faucet if you're developing on testnet. So yeah, that'll be all from my side. Thank you. Anyone has any questions? Yeah. Hmm? So yeah, so the gas price is definitely a lot less than Ethereum, but for NFT use case, probably I'll say you can choose whether you can go for POS or you can go for zk-EVM. What zk-EVM gives you, like other than POS, is that it gives you a high level of security as it's a roll up.
Okay.
So yeah.
Okay. Yeah. Thanks.
Another question. Yeah.
Hello, I could not quite understand what was meant by changing one line in the module. What was meant by changing one line in the module.exports?
Yeah. So basically, if you're developing on Ethereum or you were developing on any EVM chain, let's say Polygon POS, and you are already you already have your contracts, right? You must have deployed them using any of the smart contract development framework like Hardhat, Foundry, or you can do it via Remix as well. So technically, the whole idea was that you don't need to change anything with respect to contracts, right? You can just connect to the RPC and deploy your contract there. So in the line, I'll show you. I'm just mentioning which network I need to connect in. So if let's say I just mention the RPC URL of Ethereum here, the contract would be deployed to Ethereum. Or if I mention the RPC URL of Polygon POS, it will deploy on POS. So the whole idea of this one-line change is that it's very easy to deploy on zk-EVM, that you don't need to change anything. The dApps that you are already familiar with or you already have built, they can straight work out of the box with zk-EVM.
So actually, how can you say that you are achieving more? How can you say that you are achieving much more throughput rather than the traditional method? Although you are doing much more computation to the JK calculation you are doing. So how can you say that you are achieving much more throughput in JK-EVM process rather than the traditional method?
So you're saying with respect to Ethereum?
Yeah.
Yeah. So in Ethereum, as you know, there's a block time of 15 seconds, right? So the throughput is really less. And here, what traditionally we are doing is we are batching all the transactions and then submitting them on Ethereum. And if you see, if you're just in Ethereum, whenever you want to transact, there's a separate transaction for every transaction that you're doing, right? Every thing that you need to change the state of Ethereum for, right? But with zk-EVM, what you're traditionally doing is that you're batching all those transactions and then just submitting one transaction on Ethereum. Basically, that's submitting the validity proof to it. So the throughput is much more than that. Any other questions?
We have plenty of time, so please take advantage of the time. We still have a whole another 10 minutes. If anyone would like to ask a question, come on closer too, so we can hear you better for those in the back.
Can you hear me?
Yeah.
All right. I have a bunch of questions, I guess. So as I understand, like the whole system is basically zero knowledge proofs based rollups, right?
Mm-hmm.
How it is being batched and how it is being submitted to Ethereum.
Right.
Now, from an EVM perspective, do you have anything extra that has been added, which sort of gives smart contracts maybe zero knowledge proof sort of functionalities or something like that you can execute?
No. So from smart contract level, it's exactly the same if you compare it with Ethereum and POS. What we are leveraging zero knowledge proofs is just to scale.
for basically the roll up thingy
Yeah,
and the batch
exactly,
thingy.
exactly.
Now, which that also means that the transactions on the whole system are actually visible. The transactions themselves are not zero knowledge, right?
Yeah, yeah.
Are there any plans in which like you have either this network upgraded to, or maybe a new network in which the whole network itself is zero knowledge, so that like you basically cannot see who is doing what?
Yeah. So the thing here is that with zero knowledge, yeah. So zero knowledge here, how it is being used is that when I am transacting on Polygon ZK EVM, I am like all the transactional data stays on ZK EVM itself. It's just that the summary is posted on Ethereum, right? So if you see, Ethereum doesn't know about that data, but still it knows the state of ZK EVM. So in that sense, it's zero knowledge for Ethereum, right? But to your point, I think we don't have any plans for that, because technically, if you want the whole chain to be zero knowledge, that's actually the role of consortium or private blockchains, right? And as you know, our main vision is to scale Ethereum, which is a public chain. So we are gonna have a public chain, yeah.
Got it. I mean, you can have a public chain also in which you have zero knowledge based transaction. I think Aztec initially was trying to do that or something like that. But yeah, like that completely depends upon what the plans are. But yeah, thank you.
So through JKVM, we are creating a JK proof of our smart contract. Can we say that?
No, you technically you can say that you are technically just creating a proof of the latest state of ZK EVM and then posting it on Ethereum, so that Ethereum is aware of the latest state of ZK EVM. This is very useful when you are bridging, basically. So to bridge, if you want to do it from Ethereum to ZK EVM, you can just ZK EVM can just fetch the state of Ethereum and know that you have deposited your funds, right? But in order to withdraw back to Ethereum smart contracts or Ethereum should also be aware of the state of ZK EVM, right? So that is done via the ZK proofs.
Okay, thanks. Thank you.
Hello.
Yeah.
So from my understanding, so it's like we are having a normal Polygon chain, and this zero knowledge chain is like a different one, right?
Yeah, both are very different. So the ZK EVM is a roll up, and that's traditional POS chain.
Yeah,
Right?
yeah, got it.
This works on a consensus mechanism known as proof of efficiency.
Yeah.
So yeah, completely different chains.
Yeah. So my question is like, just from a perspective of one who develops the dApps or just a contract. So when can I like decide? Okay, this is the right time to use this zero knowledge chain. So like, can you give like maybe a direction like? How
Yeah. So basically, if you still have a lot of transactions, or you don't really, if let's say you are building a dApp in DeFi, right, or you are building a DeFi product, then security is very essential for you, right? You don't want your funds to be, you don't want someone to steal your funds or go somewhere else. I'm not saying that POS is not secured, but ZK EVM is much more secured than POS, right? So the thing is that if security is your thing, you should go for ZK EVM. But some use cases like NFTs, where you want a lot of transactions, and if you see the gas fees, it's still the gas fees on POS is cheaper than ZK EVM, right? So if you want to go for like bulk transactions and low gas fees, you can select POS.
Actually, our one of our use cases is like we want to include a lot of NFT minting. So would you suggest like go for the zero knowledge chain?
Yeah, you can totally go for ZK EVM. In that case, it'll work totally fine.
Okay, thank you.
Excuse me. can we visualize the JK proof anyhow? Like what is the JK proof of our smart contract, and can we verify the JK proof we are generating is actually representing our smart contract? Is there any way of doing that?
So you're basically saying of your smart contract?
Yeah, like our smart contract, we are creating the JK proof of our smart contract. So, like, can we say, is there any way to verify that the proof we are creating is actually mimicking the smart contract of, like,
Okay. So yeah.
prospect?
So you're not creating a proof for the smart contract. When you are transacting with that smart contract, you're creating a proof for that, right? And then basically, when you're submitting the proof, so let's say you send a transaction and that changes the state of zk-AVM, right? Now, for Ethereum to be aware of that state, you are sending that proof there. So yeah.
Yeah, I got it. Yeah, thank you.
Yeah, can you hear me?
Oh, yeah. Yeah.
Yep. So you mentioned that you have some certain opcodes which are not compatible with the zk-AVM, right?
Yeah,
Like
it's just 3 pre-compiled opcodes. Other than that, all the opcodes are supported.
yeah, like, so how can we know which are those opcodes so we can, like, avoid it in our contracts when deploying?
Yeah, so for that you can just go to wiki.polygon.technology. I can just show you quickly as well. So here's the documentation. So here's the quick start guide to actually, here you can find the RPC details about the testnet and zk-AVM. And if you go to FAQs and you go to EVM equivalence, yeah, you can just see that these precompiled are not supported. It's SHA-256, Blake, and pairings. Other than that, all the opcodes are supported.
Thank you.
Any other questions? We still have 3 minutes.
Actually, I'm trying to build a DApp, DeFi DApp, which is trying to run a job and that job will be containing hundreds of transactions.
Mhm.
So can I do that in zero knowledge?
zk-AVM, you mean? Yeah, totally.
Okay, because in Ethereum mainnet, the gas prices are exorbitant.
Yeah. So if you see with Polygon zk-AVM, the transaction fees are very low as compared to Ethereum. So even if you see the contract that I deployed, it's like only it's 0.00025 ETH is the transaction fee. In case of Ethereum, it would have been much more than that. Yeah. So you can totally use zk-AVM for deploying a app.
All right, awesome, Pulkit. Thank you so much. This was a great workshop. We are wrapping up this workshop room 2. There's going to be one more workshop right here, and you definitely don't want to miss the opening ceremony at 8 o'clock. And dinner will be after the opening ceremony. So see you main stage at 8 o'clock. Let's go.
Thank you so much.